Welcome to the video on specific heat. Specific heat is the amount of energy in calories or joules that it takes to raise the temperature of 1 gram of a substance by 1 degree Celsius. And our our units here are calories per gram per change of T. All right. So that's the units for specific heat, and a lot of our substances have known values of specific heat. And actually, the larger the specific heat, that's just a physical property of lots of substances. The larger the value is, the less its temperature will change. Okay, so if you're looking for, let's say, a metal that will heat really fast, okay, then you're going to want to look for something that has a substance with a low specific heat value. Okay. So over here, let's compare maybe aluminum and copper. Okay, so these are specific heats of some substances in this table. So if you look at these two values, the lower number is copper. Okay, so if we look back at our statement, okay, this means the more, okay, so the lower that number, the more the temperature will change, okay, for copper. Okay, and so the lower number, the more the temperature changes. And so if we compare it to aluminum, it has a higher specific heat, so the less the temperature changes. So if I was going to pick which metal I wanted to heat the most or fastest or whatever, I would pick copper over aluminum. So we can use specific heat, and we can calculate the heat absorbed given the specific heat. So you do not have to memorize, or in my class anyways, you do not have to memorize specific heat values. So here's an example. So how many calories are needed to heat a pot of 1,600 grams of water from 25 degrees to 100 degrees? Okay, so we have two temperature values, and we need to know the change of T, which means final minus initial. So it goes from final temperature is 100 minus 25. So there's a change in temperature of 75 degrees C. Okay, we're also would be given or seen in a table. This one's pretty easy to remember, but the specific heat of water is 1.00, and remember our units for specific heat is cal per gram degrees C. Okay, if we use specific heat in an equation, we have to use the same units. We have to use calories, grams, and degrees C. So this is a lot different than when we were looking at gas laws and things, because we always had to plug in moles and Kelvin. Okay, and so this one is different. Okay, so your units are cals, grams, and degrees C. Okay, our heat equation. So heat is also shown as Q in some books, but MC change of T. So either one that you want to remember. But to calculate heat, you have to take mass times specific heat times the change of temperature. Okay, and so this is just a little bit different order, so whichever one you can remember. Okay, your answer is going to be in calories because your units are going to cancel once you plug everything in. So just like we always do, we cancel our units to get the units that we are looking for. Okay, so if you think back to your problem, we had 1,600 grams of water. Okay, the temperature change was 75 degrees C, and the specific heat was 1. So remember 1, this is just the units, cals, grams, degrees C. And the answer comes out to be 1.2 times 10 to the 5th calories. So this is how we would calculate the heat based upon, this is our heat equation. And so if we want to calculate the heat absorbed, then we can plug this in knowing the specific heat of the substance that we're given in the problem, right? And so we take our change of T, we plug it in with our mass and specific heat, and then we just multiply and get our final answer. All right, thank you.